My name is John Brandis. I'm with Universal Package Systems out of Dale, Indiana. Today I'm going to demonstrate how to cut and weld a custom-sized container. When a standard container is not the right size for your product, we can modify the standard containers and make them custom. The first process of customizing the container is done with our bandsaw. We take two standard containers. In this instance, it's a 48, 45, 34. We're going to cut them down to 40 inches, which measurement's been made, and I'll have two of them at 40 inches, and we're going to start this process and go from there. This is the bandsaw we use to cut the containers down to size. I've got a belt-driven table. We've got the guide that's locked in place to measurement, and we use magnets for flexibility to move the boxes on and off the table. We're going to begin the cut. We'll start the bandsaw, get it up to speed. Once the container is cut, we will take the container off the table, move it to our next process, which is the welding process. All the scrap that we generate is set for reprocessing. After the containers are cut off the bandsaw, we bring them to this machine, which is our hot plate welder. The machine consists of tables that move in and move out. I've got a load bar right here. I've got pressure plates, or pressure feet is what we call them, that will hold the container in place like that. And we've got the hot plate, which is in the hot shield. And when we're ready to weld this hot plate, the tables will retract, the low bar will retract also. The hot plate comes down, the tables will come together, meet the plastic will melt, the hot plate will then return up, and the tables will come together and fuse the box together. When setting the container up, I've got a guide on this side and a guide on that side. The edge of the boxes are actually in line and ready to be welded. Now we'll put all of our airlocks down and demonstrate that, and we're actually going to demonstrate the full welding process to fuse the box together. Right now what we're doing is using the air clamps to hold the base in position. Kenny's going to put a support on the back. We'll lock this in place. As the box is melting, this allows us to adjust pressure on the back. Kenny is now going to basically drop the hot plate and bring the boxes together. The hot plate's set at 410 degrees Fahrenheit. Right now the edges of my base are against that hot plate and it's melting. We've got Teflon coating on it to help relieve any pull of the plastic once the hot plate goes back up. Once the hot plate goes up, what they're doing is applying pressure on both ends to help fuse the box together. Once the base is welded, we have a seam that runs down the middle. This is plastic from each side of the base that came together, and it will be cleaned up once we do the final assembly on the box. This is the finished base as it comes off the welder. Okay. This is my machine that we weld the walls on. If you remember in the stage one, we cut the walls at the same time that we cut the container base down. This is the last process of actually welding the whole container together. What we do is we put wall over here, you've got a hot plate inside of here, and this, instead of this hot plate going up, it actually goes down into the machine. This will hold the pressure, holds it in place, and we're going to demonstrate the process and go from there. What Kenny and Wayne have done is line the walls up parallel on each side of the machine. They're actually even on both sides. The air clamps hold the wall in place so it cannot move during the process of fusing. What they're going to demonstrate is the walls actually being melted on the hot plate that's inside the bars, and then it will fuse together and we'll have the finish good. All right, right now both sides of the walls are actually melting on the edge of this hot plate. Again, this is coated with Teflon. Kenny's watching the width of the weld before he decides to drop the plate and fuse the wall together. During prototype staging, we actually put a timer on this, but all the materials that we cut and weld are actually different, so melt times are different. And once the wall comes together, we hold it under the clamps in order for the plastic to cool down and settle in place and give you some stability on the wall. The container base is finished. We've got the walls finished. Everything's welded in the middle. We've got the longer walls or modified walls snapped in place. We're going to snap in the end walls and we'll have a complete unit. The container still has 4-way fork entry. I've got 2-way on the length side going through the width. I've also got 2-way on the width side going through the length. I'm going to demonstrate the weld and how it looks on the bottom of the container. When you look at the weld, you can tell your whole base is welded together. Everything's coming together real nice in the middle here, all the way around. This container, again, is 80 inches. I can build virtually any length or any width. We've done as small as a 48 by 32. The largest to date is 120 by 64. Quick review of the process. We started at the bandsaw with 2 standard containers. The standard containers are 48 by 45. I cut them down to 40 by 45. We went to the welder, welded the base. The base is now a solid base. And then we went to this process over here and welded the walls. Once we've completed our process or project, we've come up with an 80 by 48 by 34 container.